Alright, so today we're going to talk about zeros or roots or solutions of functions. Okay, so zeros is another name of saying solutions are answers to our quadratic functions. These are simply the x-intercepts of the problem. Okay. X-intercepts of the parabola. So that's, find the zeros of the following parabola. So we're going to look here. Remember the x-intercepts are the points that cross the x-axis. Okay, so our point would be here. That point or order pair would be -1, 0. The other one would be here, which is at 2, 0. So those are our zeros, our solutions. And we have 2 of them in this case. On letter B, we only have 1 of them. It's right here. It's at 1, 0. Okay? And on here, we don't touch the x-axis on letter C. So in that case, we're going to say it's no solution at all. Okay. Sometimes we're going to be asked to find the x-intercepts and graph them. So let's go ahead and talk about it. So there's 3 things you're going to need. You need the x-intercepts, you're going to need the vertex. Okay, so let's find the vertex first. In order to find the vertex, x equals negative b over 2a. B in this case is -5, so it's -5 over 2 times 1. So this is going to be -5 over 2. So our x of our vertex is -5 over 2. Okay. I'm going to put that back into our original equation. So it's y equals -5 over 2 squared plus 5 times -5 over 2 plus 6. Okay. So when you're doing the squared, you have to square both the top and the bottom. So -5 squared is 25. 2 squared is 4. When you're multiplying this number, okay, this 5 gets multiplied to only the top. So it would be -25 over 2 plus 6 over 1. Remember, when you add fractions, you have to get a common denominator. You're going to make all the denominators 4. So to do that, we're going to multiply this by 2 and this by 2. And the bottom one here, we're going to do by 4 and 4. Okay, so I'm going to get y equals 25 over 4 minus 50 over 4 plus 24 over 4. So remember, when you do this, you're going to add only the tops. So it's going to be 25. So y equals 25 minus 50, negative 25 over 4. And then 24, negative 25 plus 24 is negative 1 over 4. So our vertex is at -5 over 2, negative 1 over 4. If you want to make them decimals, just divide the top by the bottom. Okay, so I'm going to graph that. So it's -2.5 to 1/4, which is about right here, roughly. Okay. So here again, it's our function. It's y equals x squared plus 5x plus 6. We're going to do the x method. Okay, so it's going to be 6 on top, 5 on bottom. The numbers that multiply is 6, and adding a 5 are 3 and 2. But remember, when you do the solutions, it's going to be the opposite. So this would be -3, this would be -2. So on the x-axis, I'm going to graph the point at -3 and -2. And then you're going to connect your dots from the left to the right. There's your problem. Okay, let's try the next one. This one's not going to be as bad because we're not going to get a fraction. Okay. So remember, it's x equals -b over 2a. So the opposite of b would be +8 over 2 times 1. So it would be 8 over 2. So our x is 4 of our vertex. Okay, then we're going to put that into our function. So it would be 4 squared minus 8 times 4 plus 12. So again, for y. 4 squared, we would do exponent first, is 16. Negative 8 times 4 is the negative 32. 16 minus 32 is negative 16. Negative 16, we do those first. Negative 16 plus 12 is -4. So we have a vertex and 4, negative 4. Okay. So then we're going to do x squared minus 8x plus 12. Remember, we're finding the 0, so we're going to do x method, 12 on top, negative 8 on bottom. Two numbers multiply get 12, but add to get negative 8 or negative 6 and 2. But remember, when you're doing the solution, it's going to be opposite. So x here would equal 6, x here would equal 2. So let's graph the points. So we're going to graph the vertex first, 4, negative 4. So 1, 2, 3, 4. Down to 4, it's right there. And then now we're going to graph our zeros. So one's at 6 on the x-axis, and one's at 2 on the x-axis. And then you just connect your dots from left to right, and it will form some U-shaped parabola like so. Okay. Do another one. Okay. Always start with x equals negative b over 2a. So in this case, it's going to be positive 2 over 2 times 1. Which is 2 over 2, so x is 1. We're going to put that in, so y equals 1 squared minus 2 times 1 minus 15. So 1 squared is 1. Negative 2 times 1 is negative 2. 15. So that's going to be negative 1. We'll do those first. Minus 15. So our y is negative 16. So we have a vertex at 1, negative 16. Okay, now we're going to do the x method on the zeros. So it's negative 15 on top, negative 2 on bottom, which means that's negative 5 and 3. So in this case, x would equal 5, and x would equal negative 3. So this one's a little weird because I can't graph the full thing, so I got to graph 5 and negative 3, but I can't graph the negative 16 because my graph's not big enough, so I'm just going to leave a gap like so in my function on my parabola. It would look something like that. On this one, I'm going to do the same thing, but I'm going to make it a little bit easier because there's another way you can graph as well. So I want to show you a little shortcut. You still have to find the vertex because that's the bottom or top of the graph. So that's always going to be the case. So in this case, it's going to be 4 over 2 times 1. So x equals 4 over 2. So x will equal 2. Put that in. So it's going to be 2 squared minus 4 times 2. Plus 3. 2 squared is 4, minus 8 plus 3. So that's negative 4 plus 3, which makes it negative 1. So we have a vertex at 2, negative 1. But here, there's another way. This c value is my y-intercept, which means I have a point at 0, 3. So what I'm going to do is I'm going to graph my vertex first. So it's 2, negative 1. Then I'm going to graph my y-intercept, which is at 0, 3. And remember, what I know is I know there's a dotted line that comes through here. And I know that this same point is going to repeat on the other side. So see here, I am 2 units away from this one. So I'm going to go 1, 2 on the other end. And there's my third point. And then I'm going to connect them from left to right. And there you go. There's your problem. Alright, let's try another one. X equals negative b over 2a. X equals negative 2 over 2 times 1. So it's negative 2 over 2. So x is negative 1. Okay, we're going to substitute that back in. So it's negative 1 squared plus 2 times my negative 1. Plus 1. So negative 1, and again, this gives me y. Y equals negative 1 squared is just 1. 2 times negative 1 is negative 2. Do those first, so that's going to give me negative 1. It's going to give me 0. So I have a vertex at negative 1, 0. Okay? Again, take that c value. It's at 0, 1. So I can graph those points. So negative 1, 0. On the x, it's right here. 0, 1 is there. Again, here's my axis of symmetry line coming down the middle here. Got 1 unit away this way. I'm going to go 1 unit that way for my other point, and then just connect your dots from left to right. Don't forget your shape for that one. Okay. Last one. Okay. X equals negative b over 2a. So x would equal positive 2 over 2 times 1. So x is 1 in this case. Again, we're going to put it in for our, to get our y. So it would be 1 squared minus 2 times our 1 plus 2. And 1 squared is just 1 minus 2 plus 2. That's negative 1 plus 2, which is 1. So we have a vertex. Now, 1 comma 1. And again, I can graph this c value if I want. It's at 0 comma 2. So 1, 1 is here. 0, 2 is here. Again, you know this is your axis of symmetry that comes through. You're 1 unit away that way, so that means you're going to go 1 that way. Connect them from left to right, and there's your parabola.